guys, so notes on inequalities. It's basic algebraic inequalities that you've seen before, and then some word problems. So anyhow, starting out with graphing. Remember, graphing, you want to make a number line. I normally will mark 0. I also will mark the number I need here, which is 3. And if this says x is less than 3, right, you have to know your symbols, but either way, if x is less than 3, that means I leave an open circle at 3. Right here it indicates open circles are not solutions, and the closed circle indicates endpoints that are solutions. So anyhow, it's less than 3. Since it can't equal 3, open circle. And then since it's less than, I would shade or point left. Right? There's that one. Next one, same thing. Number line. Box my answer. Number line 0. Mark the number you're using, which is -1, and x is greater than or equal. This symbol says greater than or equal. So shaded circle because it's equal, and then greater than, numbers that are greater than are on the right. So shade or point to the right. All the numbers that are greater than or equal to -1. Here, the print quality is bad, sorry, but you can kind of see what it is anyhow. It's a compound inequality. If you break it up, you get x is greater than -1 and x is less than or equal, less than or equal to 3. So we can graph that. A number can be greater than -1 and less than or equal to 3. Greater than -1, open circle. Less than or equal to 3, shaded or closed circle because it can equal 3. And then numbers that are greater than -1 are on the right. Numbers that are less than 3 are on the left. So the two circles eventually kind of meet, and that's the graph of that. This is two separate inequalities that I have to solve first. So let me do that. So I'm going to subtract 1 from 4. Subtract 1 from both sides. 4 minus 1 is 3, and pretty much solving these is the same skill set as solving equations. So I get x is less than 1 on this one, and add 3 to the other one, right? This is a compound inequality using the word or. And, so I get 2x is greater than 16, divide by 2, and I get x is greater than 8. It started out with the word or, so we should keep the word or. Graphing this, it's either x is less than 1 or x is greater than 8. So I'm going to put 0 here because the numbers are both positive. Put 1 and 8. Less than 1 means open circle, point left, because it can't equal 1, and less than, you should point left. Greater than 8. Again, it can't equal 8, so open circle, and numbers that are greater than 8 are on the right, so point right from there, and that's the graph of the solution. Moving along here, this is really the only difference in solving inequalities. The only difference is if you multiply or divide both sides of an inequality by a negative number, the direction of the inequality symbol is reversed, so I have to remember to do that if I multiply or divide by both sides by a negative number. So carrying on, we add 7 to get 4x is greater than or equal to 12, divide by 4, and I get x is greater than or equal to 3. And no symbol flip, I divided by a positive 4, so no symbol flip. And then the graph here is at 3, shaded circle, right? 3 is one of my solutions. It can equal 3. And then it says greater than, so numbers that are greater than or equal to 3 would be to the right. So shade or point to the right. This one says 1/3 x is less than 5. So normally to get rid of a fraction, if the coefficient is a fraction, I'll just multiply by the reciprocal, which is 3. So that'll cancel, and I multiply the other side by 3, and I get x is less than 15, which if I graph open circle, numbers that are less than, point left. So algebraic solution, graph of the solution. Moving right along on this one, negative 3x is less than 21. So I have to divide by negative 3, and this is one where I have to switch the direction of the symbol. I'm dividing both of sides of the inequality by a negative number. So I have to switch it from less than to greater than. 21 divided by negative 3 is negative 7. X is greater than negative 7. Graphing it, 0, negative 7, negative number should go on the left. Open circle, point to the right. And again, open circle means it can't equal negative 7 because the symbol doesn't say or equal to. And I point right because greater than, right? Numbers that are greater than would be on the right. And moving right along. I am going to, this is 6x minus 12 is greater than 8x plus 2. I normally like my variables on the left, so I'm just going to move the 8x over. And in doing so, in moving variables to the left, I'm going to move the constants to the right, so I'm adding 12. 6 minus 8 is negative 2. The 12 zeroes out. Bring down your symbol. 8 minus 8 zeroes out. And 2 plus 12 is 14. And here, when I divide both sides by negative 2, I have to flip the symbol. So I have to, it was greater than, I have to make it less than. X is less than negative 7. So I'm graphing that. 0, 7. We should have an open circle because it's just less than. The numbers that are less than negative 7 are on the left, so I have to point or shade left. So this next one is really about finding an average, but I'm missing one of the values. They tell me what you want the average to be, and then I'm missing one of the values that I need to average all my values out. So, like, for example, let's say one brother or sister had $5 and another one had $8 and then another one had $10. And you said, well, what is the average amount of money that each of these siblings have? Well, you could just, you can get the average amount of money by just adding these all up, right? 5 plus 8 plus 10. And since there's 3 values, you would divide by 3, right? So that would be your basic formula, right, for finding an average. You take all the values that you're trying to average out and divide by how many there is. So let's see, what would this be? 13 and 10, that's 23. And then 23 divided by 3, is that like something like 7.6 would be my average. So I add up all the values and divide by how many there is. The problem on this one is that they give us all these test scores. 86, 88, 92, 84, and then they tell me if the average is 90, then what does the 5th score have to be? Okay. Also, there is one little note here. I know the print quality is bad, but it says that the final exam counts as 2 grades. So these are all 1 grade. And the final exam counts as 2 grades, and we don't know what the score is, but we want to average out to 90. So what we're going to do is we're going to count the final exam as an unknown, as 2 unknowns, because it counts as 2 test scores. So now if I add up all my test scores, I'll get 86 plus 88 plus 92 plus 84 plus x is plus 2x. Again, the final exam counts as 2 test scores, and it's what do I have to score on the final exam in order to average a 90? So I have 1, 2, 3, 4, 5. I have 6 test scores, so I'd have to divide this by 6, and then it is an inequality, so you must have a final average of 90, meaning your final has to be, your average has to be greater than or equal to 90, okay? That would give me an A, so again, it falls into an inequality category. Greater than or equal to 90 will get me an A. Okay, so now I can add all these up, and I can multiply by 6. I guess I can do that in the same step. I can multiply by 6 to get rid of the 6, multiply both sides by 6, and then add up all the constants. 86 plus 88 plus 92 plus 84. It's 350. So 350 plus 2x is greater than or equal to 540. Multiply there. Subtract 350 on both sides. And 350 is gone. 2x is remaining. 2x is greater than or equal to 190. Divide by 2. And you get that your final test score will have to be greater than or equal to 95% in order to average at least a 90 in the class. It makes sense though, since all these are less than 90, or actually one of them isn't, but since most of them are less than 90, it makes sense that I have to score higher than 90 just to raise my average up to a 90 in the class. And then this last one is the same thing. It says the final exam counts as 2 grades, right? If the final exam were just 1 grade, I could call it X. But since it says it counts as 2 grades, I have to call it X twice. So here's my scores. It says 82, 74, 78, and the final average, we want it to be at least an 80. And again, that's the average of these 3 scores plus the final, which counts as 2 grades. So the 2 grades, what do they have to be, right? We don't know in order to average at least an 80. Well, we'll call them X when we don't know. So again, finding the average, if I add up all the scores and divide by how many there is, so there's 1, 2, 3, 1, 2, 3, 4, there's 5 scores on this one. So if I divide that by 5, I'll have my average, which I want to be greater than or equal to 80%, as stated in the problem. So I can multiply by 5 to get rid of the 5, both sides. I can add these constants, 82 plus 74 plus 78. 234. Don't forget about that 2x. 80 times 5, 400. Subtract 234 on both sides. And 166. And divide both sides by 2. And you have your answer. So 83. The final exam, I would need to get an 83% or higher on the final just to average an 80 in the class based on having these 3 test scores prior.